Welcome to the project presentation of Group 4. Our project is concerned about the design and implementation of a laboratory variable DC power supply. We have produced a Simulink model to show the basic circuitry and setup of our project, and also implemented it in hardware to show the live functioning of the circuitry. Now we go to the Simulink diagram. The main power line comes from the mains and goes through a transformer and a rectifier circuit to produce a DC voltage of 24 volt, which we simplify in MATLAB using a DC source of 24 volt. The source goes to a buck circuitry which can control the DC output value. Then we take it to the voltage control segment of our circuit as shown here. This is a type of voltage regulator. And finally, it connects to a potentiometer circuitry which can be used to control the regulator. The second part of the circuitry comprises of a current controlling knob, which is implemented via potentiometer, and all these current controlling things are implemented via strategic BJT locations in the circuit.
Circuit to check the current values as we see in a lab DC circuit. We can opt to use the buck instead of current control or the control knob, but usage of both in proper manner allows for adequate and smooth current checking. The potentiometer in the Simulink seemed to us a bit problematic, so we switched to manual resistor control in Simulink via 2 resistor ratio, and we implemented it in physical circuit via a pot. We vary the potentiometer of the voltage control to show that Simulink or circuitry works. So here we have paired our first resistor R1 equal to 0.3 kilo ohm or 300 ohm, and our second resistor value is 0.9 kilo ohm or 900 ohm. So the ratio is 1/3. So for this, when we start simulating the circuit, and then when we go to the scope, then we will show that this is our output, where the output voltage is 5.8 volt. Again, when we change the value of a resistor in 0.1 kilo ohm, and then when we change the second resistor value is 0.6 kilo ohm, and then when again we go to the simulation, run the simulation, and then we go to the our output scope, then we see this output. Here the output voltage is 4.2 volt. So you see the voltage is varying when we changing the ratio, but we are getting the DC output here.
Now we start our hardware demonstration part. Actually, our entire circuit have two segments. First segment is the voltage control part, and the second segment is the current control part. So we start from our voltage control part. We have used here a transformer which is center tapped and with 24 volt rating. Then we come to the rectification part. Here we have used full bridge rectifier which convert 24 volt AC to 24 volt DC. Then we move to the buck converter inside the voltage control part. Hereby in buck converter we have used a large inductor, diode, capacitor, and a MOSFET which is IRF250 and the IC3524. Now we come to the second stage which is current control part. Here we have used BJT on 39 and to power BJT TIP3055 which is attached to a heatsink. Then we have used two resistors which is 5 watt and they are connected in series for protection against the short circuit. And then in the below of the car control circuit we have used a current knob, and beside we have used a secondary voltage control knob. In case we don't use the buck converter, we can use this knob, but these knob don't give smooth voltage control in the output.
Here we can see we have a power indicator. It will show that our circuit is powered on. Here we can see we have a volt ampere meter. We will use this volt ampere meter to measure the output voltage and current. We'll use a 9 volt battery to supply power to the volt ampere meter so that it can measure voltage and current accurately. Next, we'll start our hardware demonstration part. Here, firstly, we'll show our voltage control part. Here we can see if we rotate the knob counterclockwise, we can see that our output voltage increases and finally it stops at 27.3 volt. So we can say that our maximum output voltage is 27.3 volt. And if we rotate the knob clockwise, we can see that our output voltage also reduces. Now we'll start our current control part. First, let us increase our output voltage to about 5 volt. Here we can see our load is drawing about 1.7 ampere of current. Now if we want to limit our output current, we will use our current control knob. Now let us rotate our current control knob counterclockwise to limit the current. Here we can see our current is limited to about 1.3 ampere, 1.4 ampere, and our output voltage is also reduced. And if we further limit our output current, we can see our output voltage almost zero and output current is also almost zero. Lastly, we will show that our output voltage remain almost constant in case of we use a variable load. Here we will implement with a variable load using a DC motor, Arduino, and a motor driver. We will change the speed of the motor using this knob, and we will show that our output voltage remain almost negligible change. And now if we increase the speed of the motor to the maximum, we can see that our output voltage changes from 10.9 to 10.7 volt, so that we can say that the change in the output voltage is almost negligible.
So in conclusion, we can say that our model is working properly and the constraints needed for output has been met. Thank you.